Hello student, welcome to your chemistry lab. Today I am discussing chemical bonding. Here I will be discussing third part of chemical bonding, that is sigma bond, pi bond and hybridization. It is important for JEE and NEET and also board. So read very carefully. So now watching the whiteboard. Overlapping of orbitals. The overlapping of orbitals may be two types. First one is sigma bond, end-to-end overlapping or axial overlapping or head-on overlapping, resulting to a sigma bond. Here the electron density is concentrated in between the two atoms. The main example of sigma bond. First, S overlapping. S orbital are spherical. So, two S orbital are overlapping form a SS sigma bond. Next, sp overlapping. One S orbital and one p orbital head-on overlapping form a sp sigma bond. Next, pp overlapping. Two p orbital are overlapping form a pp sigma bond. Second, pi bond, sidewise overlapping or parallel overlapping, which is seen normally after at least one axial overlapping between orbitals of same atom and result to a pi bond. Here also electron density concentrates between the atoms bit on either side of line joining nuclei, as this is 2p orbital sidewise overlap form a pi orbital or pi bond. Hybridization. The valence bond theory explains satisfactorily about the formation of various molecules, but it failed to account the geometry and shape of the various molecule and bond angle. I will explain the valence bond theory in next class. Now today I will explain hybridization only. Now, the valence bond theory explains satisfactorily about the formation of various molecules, but it failed to account the geometry and shape of various molecules and also bond angles. It could not explain why BeCl2 is linear, BF3 is planar, CH4 is tetrahedral, NH3 is pyramidal, water is angular. This can explain valence bond theory. To explain this characteristic geometric shape of the polyatomic molecules, Pauling introduced the concept of hybridization. According to this concept, the intermixing of atomic orbitals of nearly equivalent energy of an atom to form a new set of equivalent orbitals is known as hybridization, and the new orbital form is called hybrid orbitals. That means when two atomic orbitals are intermixing form a hybrid orbital, and this phenomenon is known as hybridization. The main postulate of hybridization are as follows. First one, the intermixing of atomic orbital or similar or nearly similar energies and their redistribution into an equal number of identical orbitals is known as hybridization. Point 2, the atomic orbital of only atom can participate in hybridization, but atomic orbital belonging to different atom cannot participate in hybridization. Point 3, the number of hybrid orbital formed is always equal number of atomic orbital participate in the hybridization. Point 4, the hybrid orbitals are symmetrically arranged around the nucleus so that the repulsion between them will be minimum. The angle between any two hybrid orbital in an atom will be equal except sp3d and sp3d3 hybrid orbitals. Point 5. The distribution of electrons in different hybrid orbitals follows Hund's rule and Pauli exclusion principle. Only atomic orbitals undergo hybridization, but not the electron present in them. Point 6. Hybrid orbitals always form sigma bond. Each of the hybrid orbital has a larger lobe concentrated in a particular direction and is therefore able to overlap very strongly with an orbitals on another atom located at an appropriate distance and direction, and hence the bond formed by the hybrid orbital is stronger than the bond formed by a pure orbital. Point 7. The atomic orbital belonging the valence shell of the atom only participate in hybridization. It is not necessary that only half orbital should be participate in hybridization. In some case, even filled orbital of valence shell take part in hybridization. Types of hybridization. First, sp hybridization. Here s orbital and p orbital are involved for hybridization. Here one px orbital are involved. We know that p orbital are px, py and pz. Only one orbital are involved from p orbital. So here we are showing that one s orbital and one px orbital or py or pz are intermixing from a linear structure, that is 180-degree angle. Example, HC triple bond CH, that is acetylene. Here two carbon atoms are sp hybridized, and this is the orbital diagram structure are showing that. Next, sp2 hybridization. Here one s orbital and two p orbital are involved for hybridization. First, one s orbital and two p orbital are intermixing from a trigonal planar structure. Angle is 120-degree. Example, ethylene, CH2 double bond CH2, and two carbon atom are sp2 hybridized, and this is the orbital diagram structure. Here pi bond is formed and one sigma bond is formed. sp3 hybridization. Here one s orbital and three p orbital are involved for hybridization. Here s orbital, px, py and pz orbital are intermixing form a tetrahedral structure, that is angle is 109-degree 28-minute. Example, CH3 ethane. Two carbon atoms are sp3 hybridized, means tetrahedral structure, that is the orbital diagram structure. Hybridization involving d orbitals. First one is dxy, second dzx, dyz, dx square minus y square, dz square, that is the 5d orbital. sp3d hybridization. Here one s orbital, 3p orbital, that is px, py and pz, and one d orbital, that is dz square, are involved in sp3d hybridization. Now one s orbital and three p orbital, means px, py and pz and dz square, are intermixing form a trigonal bipyramidal. Angle is 120-degree, 180-degree and 90-degree. Example, PCl5. PCl5 is sp3d hybridized, and this is the trigonal bipyramidal structure. Yellow line are axial bond and blue line are equatorial bond. Here equatorial angle is 120 degree, axial angle is 180 degree, equatorial and axial is 90 degree. sp3 d2 hybridization. Here one s orbital, 3p orbital, 2d orbital, in between 2d orbital, that is dz square, dx square minus y square. Here one s orbital, 3p orbital, dx square minus y square and dz square orbital are intermixing, form a octahedral structure. Angle is 90 degree. Example SF6. Hybridization is sp3 d2, structure is octahedral. sp3 d3 hybridization. Here one s orbital, 3p orbital and 3d orbital. Here d orbital are dxy, dxz, dyz are involved in sp3 d3 hybridization and form pentagonal bipyramidal. This is the example of IF7. That is the structure is pentagonal bipyramidal. Angle is 72 degree, 90 degree and 180 degree. Prediction of geometry or shape of the covalent molecules. A value of H, that is the steric number 1, 2, 3, 4, 5, 6 and 7, that we are calculated by some formula. And when value of H, that is the steric number, is 2, hybridization is sp, geometrical structure is linear, angle is 180 degree. Value of H equals to 3, that is the steric number is 3, hybridization is sp2 hybridized, trigonal planar, 120 degree. For 4, hybridization is sp3 hybridized, tetrahedral structure, 109 degree, 28 minute. Value of H equals to 5, hybridization is sp3d, trigonal bipyramidal, angle is 90 degree, 120 degree and 180 degree. Value of H, that is 6, that is steric number is 6, hybridization is sp3 d2, structure octahedral, angle 90 degree and 180 degree. Steric number 7, hybridization sp3 d3, structure pentagonal bipyramidal, angle 72 degree, 90 degree and 180 degree. For BF3 molecules, we know that valence electron of bromine is 7 and also fluorine is 7. Here first the central atom. Here central atom is bromine. Number of valence electron is 7 plus 3 into, here fluorine have 3 into valence electron of fluorine, means 3 into 7 equals to 28. 28 first divided by 8 for octet rule for one pair electron, and one pair electron equals to 3 and remainder is 4. Next we are divide for lone pair electron, means 2, and given result is 2, means 3 bond pair electrons and 2 lone pair electron. 2 all are added, means bond pair plus lone pair equals to 3 plus 2 equals to 5, that is steric number is 5. We know that the steric number is 5, its structure is trigonal bipyramidal, hybridization sp3d. I think you are enjoying to watch my video. I think you are understanding the all points, and if are not clear, so comment me, I will be replied you. If you are need to discuss for any topics, please comment me, I will be discussing for you. So thank you everyone, bye bye.